Welcome back. This is an Aleks homework video on using thermodynamic data to calculate K. So if you're given temperatures and things like that and you want to find the equilibrium constant, you are forced to go through an equation that's got G in it, the free energy. So the formula is the standard Gibbs free energy, the standard available energy, equals the gas constant, negative gas constant, times the Kelvin temperature times the natural log of your equilibrium constant. Okay, so that's probably one to memorize. Any time that you need to have K involved with either free energy or temperature or something like this, this is where you go. So knowing that, we're going to then mine the data resource. Okay, I like how they said it. Anything you can find in the data resource. Well, you have to find G. That's what you have to find. You have to find delta G. How are you going to do it if you have an equation? So I remember when I first learned how to do K, and you wanted to do that, you do the products minus the reactants, and then you have to relate the amount of moles to it. So if you want to find the energy, you find the formation energy, how much energy it took to form CCl4, and then you realize carbon is like a starting material. It's just carbon. It's not a compound, and chlorine gas is also chlorine in the free state. So these are not going to have a formation energy because they're already formed. They're not actually needing to be formed. They're already the starting products. So you are simply going to you're going to find the formation energy of CCl4. And in this case, I've got 1 mole there in this balanced equation. So it's 1 times the 1 mole times what I found. Okay, now I had to be careful. I actually wrote this down wrong. This says it's in the gas form, and on the data table there's one in the solid and liquid and gas, and you have to be careful. So in the gas, it takes negative 68 kilojoules. So there's actually a release to turn into a gas times 1 mole. And then I'm going to subtract the carbon, which is 0 since it's already in the free state, and also chlorine gas is 0. So I would have had to take it times 2, since in the balanced equation I've got 2 in the coefficient there. But since these are all just natural starting products or starting blocks, I just have the negative 64 kilojoules. So that's how much energy is released whenever you make carbon tetrachloride. So I'm just going to put it in this formula. So I fill out everything I know. I'm going to use the joules over Kelvin gas constant, and then I have to instantly recognize that I've got kilojoules and joules in the same thing. I need to put them both in joules. So I'm going to redo that. So I have 6.40 times 10 to the 4th joules over my gas constant over my Kelvin temperature equals the natural log of my equilibrium constant. I found out what it is. And then if you want to find K, you have to do the unnatural log, which is e to the x. So you're going to take the natural log e on your calculator, and there's an e to the x button, put in 25.87 as your x, and you get the equilibrium constant as 1.63, etc., times 10 to the 11. Then I'll look up, and it wants me to do it in 2 significant digits, so I have 1.6 times 10 to the 11. Very straightforward problem, a problem like you would see on a chapter exam. Doesn't mean anybody likes it, but it starts with a formula. You find something, fill in the information. So it's rather straightforward, even if it's a little bit nasty. I hope you're learning a lot, and I hope these videos are helping you.